Hi students, this animation and description would help you to learn physics even more easier and better. So please do watch it and enjoy learning physics. Moving coil galvanometer. Moving coil galvanometer is a device used for measuring the current in a circuit. Principle. Moving coil galvanometer works on the principle that a current carrying coil placed in a magnetic field experiences a torque. Construction. It consists of a rectangular coil of a large number of turns of thin insulated copper wire wound over a light metallic frame. The coil is suspended between the pole pieces of a horseshoe magnet by a fine phosphor-bronze strip from a movable torsion head. The lower end of the coil is connected to a hairspring of phosphor-bronze having only a few turns. The other end of the spring is connected to a binding screw. A soft iron cylinder is placed symmetrically inside the coil. The hemispherical magnetic poles produce a radial magnetic field in which the plane of the coil is parallel to the magnetic field in all its positions. A small plane mirror M attached to the suspension wire is used along with a lamp and a scale arrangement to measure the deflection of the coil. Theory. Let PQRS be a single turn of the coil. A current I flows through the coil. In a radial magnetic field, the plane of the coil is always parallel to the magnetic field. Hence, the sides QR and SP are always parallel to the field. So, they do not experience any force. The sides P, Q and R, S are always perpendicular to the field. PQ is equal to RS is equal to L, length of the coil, and PS is equal to QR, that is equal to B, breadth of the coil, force on PQ. For BI into PQ is equal to BIL. According to Fleming's left-hand rule, this force is normal to the plane of the coil and acts outwards. Force on RS, F is equal to BI into RS is equal to BIL. This force is normal to the plane of the coil and acts inwards. These two equal, oppositely directed parallel forces having different lines of action constitute a couple and deflect the coil. If there are n turns in the coil, moment of the deflecting couple is equal to NBIL into B is equal to NBIA. When the coil deflects, the suspension wire is twisted. On account of elasticity, a restoring couple is set up in the wire. This couple is proportional to the twist. If theta is the angular twist, then moment of the restoring couple is equal to C theta, where C is the restoring couple per unit twist. At equilibrium, deflecting couple is equal to restoring couple. NBIA is equal to C theta. I is equal to C divided by NBA into theta. I is equal to K theta, where K is equal to C divided by NBA is the galvanometer constant, that is, I directly proportional to theta. Since the deflection is directly proportional to the current flowing through the coil, the scale is linear and is calibrated to give directly the value of the current. Thank you for watching. Please subscribe this channel for more videos.